In 1732, an Englishman by the name of Christopher Robbins invented a device called a ballistic pendulum, which allowed a person to measure the speed of a bullet fired from a gun. And now the diagram is in your the lab notes, and it looks like this. It looks like a bullet that's fired from a gun, like that. It goes into a pendulum, like that. And once it enters the pendulum, then it swings up to a certain height, like that. Now the idea in this experiment is to fire the bullet into the pendulum. So for that we use the law of conservation of momentum. So here we have the mass of the bullet times the velocity of the bullet plus the mass of the pendulum times the velocity of the pendulum. And then after impact, they stick together. So we have the mass of the bullet plus the mass of the pendulum times the speed after impact. Did that show up on the?
Yes.
Everything all right? Now let's look at the problem in the lab manual. And so, for example, the velocity of the bullet might be 10 meters per second. And the mass of the bullet might be 10 kilograms. All right? Kilograms. And the velocity of the bullet might be 1 meter per second. The mass of the pendulum might be 20 kilograms. But initially it's not moving. So its initial speed is 0 meters per second. Then after impact, you have the two of them added together, 10 kilograms plus 20 kilograms times the speed after impact. Now 10 times 1 is 10. So that would be 10 kilogram meters per second. The pendulum's not moving, so that's going to be 0. And after impact, it's going to be 10 plus 20, it's going to be 30 kilograms times the velocity after impact. Now, dividing both sides by 30 kilograms, this side cancels out. 10 divided by 30 is 0.3. So the velocity after impact would be 0.3 meters per second. And when you shut it off at that point. Okay. Step 2 in Robbins' attempt to figure out the velocity of the bullet is, or in this case to figure out the height of the pendulum, is after impact, the kinetic energy after impact becomes potential energy at the top of motion. Now the formula for the kinetic energy is 1/2 mv squared. So after impact it's going to be 1/2 the mass of the bullet plus the mass of the pendulum times the speed after impact and then it becomes potential energy, which would be the mass of the bullet plus the mass of the pendulum times gravitational acceleration times the height. And as you can see, looking at the two sides of the equation, this is the same as the mass on the other side, so they'll cancel out, like that. Now what we will end up with is 1/2 of the speed after impact squared will be equal to 9.8 meters per second squared times the height. Well, the speed after impact was 0.3 meters per second squared. This is 9.8 meters per second squared. And there's the height, the maximum height that the pendulum plus the bolt will reach. Now 0.3 squared is 0.09. Meters squared per second squared. And then 9.8 meters per second squared times the height. Well, 1/2 of 0.09 is 0.045 meters squared per second squared. And this is 9.8 meters per second squared. And so therefore the height will be 0.045 meters per second squared divided by 9.8 meters per second squared. And using your calculator, that should come out to be about 0.005. Meters. And that's the end of this experiment. All right, in 1742, Christopher Robin, an English scientist, figured out the way of determining the velocity of a bullet fired from a gun. He used this equipment right here. It's called a ballistic pendulum. The gun is right here. The bullet's loaded into the gun. He fires it, and what happens is the bullet will penetrate this block, and they'll swing up a certain height. By measuring the height, knowing the mass of the pendulum and the bullet, he was able to go back and figure out the velocity of the bullet. So I'm going to do this right now. Ready? Here we go. Like that. And my assistant, do you want me to do it again?
Yes, please.
So my assistant is telling me what to do. That's fine. I'm going to load the gun again. Go back here. And we're going to fire the gun again so you can actually see this part now swinging up. Just like that.